Hi, in this video we'll talk about rational functions. A rational function is a function f of x in the form of p of x over q of x, where both p of x and q of x are polynomial functions and the q of x is not zero. Here are some examples of rational functions. F of x is equal to 3x minus 4 over 2x plus 1, and g of x is equal to x squared plus 3x plus 4 over x squared plus 1. Both of these are rational functions because the numerator and denominator are both polynomials. The bottom graphs are the graphs of these rational functions, respectively. To find the horizontal asymptote of a rational function, we first recognize that this is the y value, called k, that a rational function approaches as the x's go to infinity, negative infinity, and to infinity. So it's a value, a horizontal line, that the graph approaches when you go to the left and you go to the right. Since it is a horizontal line, it's written as a horizontal line, y is equal to the value k. The rules for finding horizontal asymptotes depend on the degrees of the numerator and denominator. Recall from our lecture that the degree of a polynomial is the largest exponent in that polynomial. So we look at the degree of both the numerator and denominator. In this table, the numerator is called p of x and the denominator is called q of x. So the degree of the numerator is less than the degree of the denominator. When that occurs, the horizontal asymptote is y equals 0. When the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is equal to the ratio of the lead coefficient of the numerator over the lead coefficient of the denominator. And when the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. To find the vertical asymptote, first recognize that a vertical asymptote would be the value of x that makes the denominator 0 if you have already reduced the rational function. In other words, you've canceled off as many factors as possible. The vertical asymptote is a vertical line, so it is written as x equals k. Here's an example. Find the horizontal and vertical asymptote of f of x is equal to 2x minus 8 over x minus 5. Then graph the function. To start with, we want the horizontal asymptote. To find the horizontal asymptote, you look at the degree of the numerator and the degree of the denominator. Both degrees are 1, since the highest power in each of those is x to the first power. When the degrees are the same, you take the ratio of the lead coefficients from both the top and the bottom. The lead coefficients here are 2 and 1, giving me y is equal to 2 over 1, which is equal to 2. When you graph the horizontal asymptote, it's a horizontal line at y equals 2, symbolized by the dashed gray line in the graph. To find the vertical asymptote, set the denominator equal to 0. This is x minus 5 equals 0, which gives us x equals 5. The vertical asymptote corresponds to this vertical dashed gray line and shows how the function approaches that line on both the left and the right side. As far as graphing the function itself, it's usually helpful to graph the zeros or the roots as x-intercepts. To find the 0 of a rational function, take the numerator and set it equal to 0. So 2x minus 8 equals 0 gives me x equals 4, and notice that we have an x-intercept at the point 4, 0.